Hello everyone. Today we will be presenting our housing affordability data system. This data system consists of data for 15 years from the American Housing Society, and we will be using cloud computing. My group, Group 7, consists of Rayan Myrie, Karan Shaw, and Anyo Sam Thomas. What was the motivation for us choosing this data set? Why did we think that the data set was interesting and important? The main reason was it satisfied the three defining properties of big data. The first defining property was volume. It consisted of large amounts of data for 15 years. The next was variety. It had multiple data types and 99 columns in the dataset. Also, the velocity. The volume and velocity of the data makes it perfect to test the speed of the data processing. The next reason was the interestingness of the measures. It was perfect for data analysis. We could perform data analysis to compare house prices versus wages to determine a correlation. We could also determine the mean wage and burden per household per region per year. And this would help us understand rent, zoning, and population. It could benefit from parallelism. It was in a semi-structured format, and the dataset was large and files were not formatted the same. It could also benefit from a one-step process where we load and process the data faster and more efficiently in one or two steps. And the final reason for us choosing this was data mining. Organizing and consolidating the data can eventually help us understand and perform predictive analytics on the data set in the future. Some of the analysis we performed on the data set were we found the maximum and minimum rent in each region by calculating the average rent and determining the maximum and minimum rent in each region. Also, we found the percentage change in rent from the previous year. The second analysis we performed was to find the average burden in each region. Burden is used to determine the housing expenditure of an individual related to their income. This gives us the correlation between rent and income in each region. Third, we found the minimum and maximum salary in each region. We calculated the average income and determined the maximum and minimum income in each region. Then calculated the change in income from the previous year for all consecutive years. Finally, we tested the performance by determining the fault tolerance and the scaling of the EMR. First, we checked the performance variation as the amount of data increased, as well as check the performance when the data remains the same and an instance failed over. So let's discuss the design. We got the data set from the American Housing Society and we downloaded the file from huduser.gov. The dataset consisted of 15 files, a total of 633 megabytes. We needed to review the data dictionary because not all fields were formatted the same and in the same position or in the same format. We also did some pre-processing of the data and we had to review each field to determine which tool would be best for us to use to pre-process the data. To your left, you'll see an example of the data dictionary. So once we reviewed the data dictionary, we applied the KDD methodology. We use the data dictionary to understand each field, determine the key fields needed to perform analysis. Then we rearrange each key field to appear first using Excel. We also use Power BI to QA our work. In addition, we formatted the data in the fields so all fields in the 15 data sets matched. After we performed knowledge discovery in the database, we determined that there were 6 key fields. Control unit. It was a unique AHS ID used to link other tables in the future. Region. There were 4 regions coded values 1 to 4, 1 being Northeast, 2 being Midwest, 3 being South, and 4 being West. FMR, which is a fair market rent. It was a monthly cost of each unit. Total salary, the sum of wage and the salary for all members in the household. Z-Inc. 2, the household income of the family. And burden, the monthly housing cost divided by the household income. The greater the value of the burden, the more expensive it was to live. The lower the value, the more affordable the housing.
Now we will see the design of the EMR cluster. that is the Elastic MapReduce. The default EMR cluster consists of the many pre-installed software that is being used for the big data applications, such as Hadoop, Hive, Hue, and many more. We are going to use EMR 5.23.0 with the Hadoop 2.8.5 along with the Hive and the Hue. It also provides the security feature and the auto-scaling feature. The cluster consists of the one master node and the two core, that is the slave nodes. Each consists of the 8 core processor and 15 gigs of RAM, along with the 80 gigs of storage. Now the implementation part. So before looking into the actual implementation of our project, let's look the difference between MapReduce and the Hive. We are comparing the MapReduce as we have used the MapReduce for our previous applications and we have used Hive in our current application. MapReduce is the compiled languages. We can write the code for MapReduce in Hadoop using Java, while the Hive is the query language. So you can just write the normal SQL queries to get the information and the results. MapReduce is the lower level of abstraction. That is, we have to write much more code and we have to manually write the MapReduce functions. While we can just write the SQL statements and get the information using the Hive. On the right hand side, we can see the basic architecture of Hive. It consists of the JDBC and ODBC applications. So depending on the SQL query language, it will process through the clients and pass the data to the Hive server. Internet process the data through the Hive driver and send it to the file system. Through the file system, we will get the information from the Hadoop cluster. Now the actual implementation of Hive SQL files. So before processing into the Hive, we have to clean the data. So we call it as a pre-processing. So we need to collect the data and clean it to the proper format and correct the data. After that, we have to set up the EMR to use the Hive along through the new web interface. After connecting to the EMR, we need to migrate the data to the HDFS file system. And through the HDFS file system, we need to load the data into the Hive databases. After the loading data, we can write the Hive queries to get the desired results. And once we get the desired results, we can export into the Excel or any other format and plot the graphs or apply some machine learning knowledge to get the informations or predictions. Once the implementation is done, we can evaluate the sum of the features from the datasets. First of all, we are calculating the income from the dataset. We are calculating the minimum and the maximum income for each region. So on the left hand side graph, we can see that there is a maximum income in the year 2003 for the region South, and in the same year there is a maximum income for the region West as well. And on the right hand side, we have compared the average income and income change, that is percentage change for every year in each region. So we can see that there is an income decline for every region in year 2005, and there is a major decline in income for the year 2013 for the region West. Similar to income, we will evaluate the rent. So we can find some correlation between income and rent and the housing properties prices. On the left hand side, we can see that there is an increment in the rent for every region after year 2001. And we can also see that the minimum rent for every region is almost same over the last 15 years. Also on the right hand side, we have compared the average rent increase or decrease for every region. So we can see that there is a rent decline for the year 2011 and 13 for the region Northeast and the West respectively.
Next, let us evaluate burden. So basically, burden gives us the percentage of income that has to be kept apart for rent each month. So we have the average burden on the y-axis that is given over the years for each of the regions, each of the four regions. So you can see initially it's in 1985 it's around 23% and it's around 28% for 2013. We can see that it's slightly increasing over time. Now, ideally, the burden should be less than 30%. Another interesting thing is that uh, the burden is consistently higher for Northeast and West regions when compared to the Midwest and South regions for all the years. So, all this shows that housing has become less affordable over time. This is especially true for Northeast and West regions. Next, let us compare the change in average rent and the change in average income together. So on the first bar, we have the change in rent, And on the second bar, we have the change in income for the Northeast region, and this repeats for all the other regions. So we can see a slight correlation between rent and income in the graph. In general, when there is an increase or decrease in rent, there is also a similar change in income. And until 2001, this change has been positive. With some increase in rent, there is a higher increase in income, barring a few exceptions. But from 2003, barring a few exceptions, we see a negative trend where increase in rent is much higher compared to the change in income. So you can see here, like the Northeast region, the income increased, sorry, the rent increased by around 9%, while the income increased by only around 3%. And for the West region, if you take, it's around 15% increase for the rent and 3 to 4%, 2 to 3% decrease in income percentage. Next, we evaluate the performance of the system. First, we check the scalability by keeping the number of cores constant while increasing the input size on each run. As expected, there is an increase in runtime when the input size increases. However, this is less than a linear increase and thus the system can handle much larger loads easily. To check the fault tolerance, we ran the jobs from 4 cores and killed a core for each rerun. So we can see that the runtime increasing with reducing cores except when run with 2 cores. So what happened here is that the EMR automatically spins up a new instance and then this takes some time but it gets added to the cluster after some time. So what happened here is that when we ran this job, a new instance had already spun up and gotten added to the cluster, and that is why it took less time to complete when compared to 3 cores. So this really illustrates the fault tolerance capability of EMR and ability to maintain its performance. Coming to the conclusion, we were able to determine a lot of insights from this data. Specifically, we were able to see that housing has become less affordable over time. We were able to see how rent correlates to income. Also, we saw how affordability changes over each regions. Also, we saw how Hive and MapReduce helps us to easily work with huge amounts of data and to extract meaningful information from it. Furthermore, we saw how the EMR platform is highly fault tolerant, where it can easily spin up new instances when one goes down. Quickly going over some of the challenges and drawbacks that we faced, we found some difficulty in extracting the meaning of some data points as they were not provided. Over the years, the American Housing Survey data formatting changed, so we had to fix it to a uniform format. Also, there were some erroneous and incomplete data that had to be filtered out from the dataset. Finally, citywide or statewide information was not publicly provided, so we had to work on regional data instead. This concludes the presentation on the housing data. We really hope that you found this information helpful. Thanks a lot for watching.